Hey everyone, we're Team 4 and we'll be discussing imitation learning. Imitation learning is a technique in machine learning where models mimic expert demonstrations to learn tasks efficiently. You're essentially given demonstrations or demonstrators, and the goal is to train a policy to mimic these demonstrations. Some of the key terms associated with imitation learning can be seen on the right side. State, represented by S, is the current condition or observation. Action is the decision that is taken in response to the state. A policy is a function that maps states to actions, and rollout is a sequence of actions and states generated by the policy over time. You can see an example at the bottom here. Imagine you want to train a Mario Kart to drive on the rainbow road. In this case, your state is the game screen, and your action is the turning angle of the car to stay on the road and not fall down. Your goal is to essentially train a policy to maintain the cart on the path and not fall. On the right side, you can see a video clip of a car driving down the road. That is ALVIN, which stands for Autonomous Land Vehicle in a Neural Network. This is the earliest example of imitation learning used for self-driving cars. It was part of an experiment conducted by researchers at CMU in 1989. They recorded a human being driving down the exact section of road and fed these recordings as an input to train a model to mimic and autonomously navigate in a similar manner. Obviously, both imitation learning and self-driving cars have come a long way since then and have more advanced techniques associated with them. Now let's look at some advantages and disadvantages of imitation learning. The easiest advantage to notice is that imitation learning is much faster than reinforcement learning as it does not require multiple trial and error methods. It also reduces the complexity of the problem because it's just directly mimicking an expert action and does not need a reward function or to optimize a reward function as done in reinforcement learning. But there's some disadvantages with it where it cannot generalize to unseen scenarios which are not covered in the training data. And another huge issue is that it's hard to collect high quality expert demonstrations. The following slides will discuss more about imitation learning and their methodologies in detail. Thank you.
Hello everyone, this is Puneet. I'll be discussing how imitation learning is implemented. Imitation learning is crucial for systems like self driving cars, allowing them to replicate expert behavior by observing examples. I'll walk you through two widely used techniques. First, we have behavior cloning, BC. It treats learning as supervised learning, where the agent learns a policy pi theta a with respect to s by minimizing a loss to match expert actions. However, BC struggles with covariate shifts when the agent encounters unseen states. The Dagger algorithm addresses this by iteratively updating the policy with new data from the learner. Next is inverse reinforcement learning, IRL. Instead of learning actions directly, IRL focuses on inferring the underlying reward function that explains the expert's behavior. The agent optimizes its policy to maximize inferred rewards, making it more adaptable than BC by learning the motivations behind the behavior. As we can see from the illustrations on the right, BC relies heavily on mimicking the expert behavior directly, which may fail in unexpected situations, while IRL learns the underlying goals, leading to more flexible behavior. That's my part. Now on to Pranay.
Hi, this is Pranay again. Um, so, when imitation learning has so many disadvantages, why do we still use it? Imitation learning permits us to model complex tasks without having a predefined policy. With today's technology, we can collect a rich data set using multiple sensors easily. Because we have access to expert policy, the time spent in learning is significantly reduced. In real life tasks like driving a car or teaching a robot how to walk, um, defining a reward function is challenging, which can be overcome using imitation learning. Moving on to conclusions and limitations, we've seen how imitation learning is essential in complex real life tasks. It definitely has issues in generalizing states. It has not been trained on. Coming to future work, we need to understand various optimization methods and weigh the pros and cons. Here is a list of papers we have referred to make the report. Thank you.